So 80 millimeter binoculars are going to be better for astronomy purposes than a 50 millimeter pair of binoculars, but an 80 millimeter pair of binoculars will be much heavier too. So just think of that if you're considering buying binoculars. I find the last thing to remember with binoculars is field of view. That's basically how big of the sky you've got in your binoculars at any given time. And for reference, the sun or the moon in our sky is a half a degree in size, in apparent size in our sky. And binoculars are also measured in degrees. Basically, a good wide angle binocular for astronomy purposes must have at least 5 degrees, if not more, of a field of view. So again, larger the aperture, the better. Keep an eye on the exit pupil and get as large a field of view as you can. So those are basically understanding the specs on binoculars. Okay, so before we get into a tour of the night sky, I just wanted to speak for a few minutes about the types of objects we have in the sky and what they really are. What is a nebula? Is a really good place to start. 100 years ago or so, almost anything in the night sky was considered a nebula. If it was fuzzy and they couldn't explain what it was, they call it a nebula. And there were a lot of them. One astronomer, William Herschel himself, cataloged over 2,500 of them. These days, our understanding of the universe has improved. Still, it's a ways to go, I think, but it has improved. And a nebula is defined typically as just a vast cloud of interstellar gas, typically of hydrogen and helium. Basically, these are stellar nurseries, which are star-forming areas where baby stars are being born as we speak. This picture here is of the Lagoon Nebula in Sagittarius. It is a typical star-forming region. All these stars here are baby stars that formed within the nebula in the last million years or so. And in the scheme of things, a million years in the universe is a blink of an eye. I liken it to like a bag of popcorn in the microwave. You get one, all of a sudden that star with its energy and its radiation goes out in the, all that goes out into space around it, and all of a sudden you get 2 and then 3 and then 4 stars forming in very short order. Diffuse nebula are a type of nebulae. These are typically what I was referring to as the place where stars are being born. They're typically called hydrogen or H2 regions in space, and typically you see them a lot in spiral galaxies like ours. There's other types of nebulae. We're not going to talk as much about them here because typically the only kinds of nebulae you can see are planetary nebulae and these diffuse nebulae, these emission nebulae, which we'll talk about in a second. Reflection nebulae and dark nebulae are the next 2 most important kinds, and I really thought hard about this. I couldn't think of any that we could see with binoculars, so I'm keeping them out for this particular presentation. As mentioned, emission nebulae emit radiation from ionized gas, typically hydrogen, but with some helium and some other compounds and elements. Baby stars are being born as we speak. For example, here's the Great Orion Nebula that most people are familiar with. It's visible in the winter sky. And then also here's the Trifid Nebula, which is an interesting nebula in that it has the emission nebula part where stars are being born. But then up here, what this blue area is actually a reflection nebula. Stars aren't being born here, but the gas is reflecting light from this bright star, kind of like a lantern lighting it up. That's called a reflection nebula, and they're typically blue. And then the dark lanes that are here that you guys can see are actually dust that are blocking the view of what's behind it. These are heavier compounds, carbon and things like that as well. So I think I already spoke about these 2. So okay, so that's it for nebulae. So the way I tend to do these presentations is I talk about like the birth, life, and death of the universe. Nebulae are where stars are born, where things start. When they birth stars, they typically form open star clusters. Here's the famous Pleiades that most people know of. It's called the Seven Sisters. It's called Subaru. There's all sorts of names from all sorts of parts of the world for the same cluster. It's a young open cluster. This cluster is also about 1 million years or maybe 2 million years old. And it's so young that these stars haven't eaten up all the nebula yet. So you can see some of the nebula here, right? Now, I should also say, when you look up in the sky with binoculars, you are not going to see color. Our eyes are not sensitive enough. So these are with long exposure photography. But it still holds that these stars, when they're done eating up all this gas, it'll be gone, and all you'll have left are these open cluster stars. Typically, open clusters have tens or hundreds, maybe 1,000 stars to them. I think the Pleiades in total has about 450. And down here, the double cluster in Perseus, there's actually two open clusters that you can see with binoculars or side by side in the Milky Way. These are, I believe, about 200 stars each, give or take. So a few hundred stars over time, they will not stay together. So our sun actually started as a baby star in an open cluster 4.6 billion years ago. And it goes around our Milky Way galaxy once every 250 million years. So it's been around the sun about 18 or so times now, and its sibling stars have gone their separate ways. And so it's actually a search now of trying to find some of them, but it's really hard in a galaxy of 120 billion stars. So the other thing too I like to talk about is distance. So with open clusters, we're only talking about things that are a few hundred, maybe a few thousand light years away. So for the Pleiades, for instance, they're only 430 light years away, which is right down the street in astronomical terms. The double cluster is a little bit further. These clusters are 6,800, which I believe is this one, and then 9,600, which is this one. It's a little bit further away, but still not too far. So that's a little bit about open clusters. Globular clusters. These are some of my favorites. So globular clusters are very different than open clusters. These are gravitationally bound. I call them star cities. And they will last for eons. Many of the more famous ones are more than 10 billion years old. So unlike open clusters, which only stay around for a few million years before they disperse, these globular clusters stay together for pretty much forever. And they typically form in the halos of galaxies, the cores of galaxies. And so there's not a lot of understanding on how or why some of these globular clusters form the way they do. One theory is that some of them are actually former cores of other galaxies, because galaxies do eat other galaxies. They merge and they take matter away from each other. And it could be that some of these globular clusters used to be the cores of other galaxies that our galaxy captured many billions of years ago. And all we're seeing left is the remainder. So remember we talked about open clusters being a few hundred light years away, or a few thousand. Look at the globular clusters here. M13 is called the Great Hercules Cluster. This is a very easy binocular target. This one contains over 300,000 stars, and it's about 23,000 light years away. M3, which is in the constellation Canis Venatici, the dogs, is about 33,000 light years away, and it's 174 light years across. Open star clusters are just tens of light years across. These are much bigger, much more grand objects. M3 actually holds about 500,000 stars. So these are, I love finding globular clusters and binoculars. They're easy to do. They look like bigger fuzzy stars in binoculars. And then of course, when you get a telescope, you can actually get them to look more like this than they do, as they do in these pictures. The next thing I want to talk about is, so we've talked about the birth of stars and nebulae. We've talked about the life cycle of stars going through open clusters and globular clusters. Now we're going to talk a little bit about death of stars, and this is bringing us to planetary nebulae. Planetary nebulae are where stars like our sun will end up at the end of their life cycles. Smaller to average size stars. Bigger stars explode as supernova, and for the life of me, I couldn't think of any supernova that are visible in binoculars, so I didn't include them in this presentation. But just think of planetary nebulae as average and small size stars and how they die. Basically, what happens is stars when they're going through a life cycle, it's called the main sequence. And during that time, they're burning through their hydrogen and then into helium. And during this time, they're happy. Stars are basically the outward force of pressure from fusion, colliding with the inward force of gravity. And if you look in the sky, the sun doesn't change its size ever, right? It's always the same size in our sky. And basically that's because the outward force of pressure and the inward force of gravity have equalized perfectly at that size. But what happens when the sun burns out of its hydrogen, expected to be in about 3 or 4 billion years or so? Well, it starts burning through other elements. First it'll go through helium, and then it'll go through other heavier items, or elements, I should say. Once it goes into carbon and oxygen, it goes to what's called the helium phase. During this time, the star will actually just burp out its outer shells. So they go out into space. Think of it as the outer 80 or 90% of the star just go off into space. Okay, essentially as a set of concentric rings or so as such. And what happens is they're getting light from what's left of the star, the core, which becomes a white dwarf star, but they're also impacting into the dust and other interstellar medium that they're running into. So this causes a reaction which lights them up. So the star is dying. All that's left is a white dwarf. But for about 20,000 years or so, it's party time. And this is what we can see. So these are actually a few of the more famous planetary nebulae that we can see with binoculars. Here's the Dumbbell Nebula, and here's the Helix. Again, when you look through binoculars, you're not going to see the color, and you probably won't even see the detail. The Helix is actually pretty big. You'll definitely, under a dark sky, and these are all under dark sky is what I'm talking about, you can definitely pick up the oval. It's a big donut. It's almost the size of our moon in appearance size in the sky. It's like, I think it's just about 1/3 of a degree in diameter. And this one is called the Helix. It's in the constellation Aquarius, which is a fall constellation for us in the evening sky. This one's about 790 light years away and about 3.4 light years across. You also notice the ages of these, 10,000 years. So about 10,000 years ago, this little star in the center, which is a white dwarf, burped out all this matter. And it's basically floating out into space. And after another 10 or so thousand years, this matter will get out so far that it's not cohesive enough for us to see anymore, and it'll just fade away. Think of it like a smoke ring. You know, for smokers, when they create the rings, they just fade out. That's what these will be doing as well. These are some of my favorite objects as well to look for. Finally, we're going to come to galaxies, the big metropolises of the universe. Once thought to only be all within our Milky Way, now we know that galaxies go out for billions and billions of years, and light years, out into the universe. Our universe is roughly 13.7 billion years old, and with the Hubble Space Telescope and other instruments, we can see galaxies almost all the way back to at least 12 billion years or so. So they formed early on in our universe, and over time they've collided with each other, they've eaten each other, they've carved out their own superclusters, and we can see some of these galaxies faintly in binoculars. Some are brighter, like the Andromeda Galaxy is really bright. You can see that with your naked eye. It's so big, and we'll talk about that in a little bit. But most galaxies are small, fuzzy patches, even in telescopes. But some are bright enough that you can pick up in binoculars. The types that we'll talk about here are ellipticals and spirals. But there are other kinds as well, as I show here. Elliptical galaxies are basically huge galaxies that over time have eaten up all the surrounding galaxies and have merged into one blob. They're so big and so massive that they're featureless. There's no spiral shape, there's no structure to these. They look the same whether or not you're looking from the top or looking from the side. They're just blobs and they're huge. Some of these are 20 times bigger than our galaxy in terms of mass. And a lot of these anchor galaxy clusters. So for example, in Virgo, we have what's called Markarian's chain, which is a system of about 23 or so galaxies that are gravitationally bound. And they anchor the greater Virgo supercluster of galaxies. These two galaxies here are called M84 and M86. These are monsters. They have a few trillion stars, whereas our Milky Way has about 120 billion stars. And they anchor this cluster, and literally there's a chain here you can see through telescopes of galaxies that go even outside of our field of view here. A lot of these are spirals, but they're anchored and they actually orbit around these two here in the center. This one here on the left is called M87, and actually it's very close to these other ones. It's just off the field here where my cursor would be. And this is one of the biggest galaxies we know. This one has well over 1 trillion stars. Our Milky Way galaxy has about 150 globular clusters. This one has at least 13,000 that they've identified. And it's almost 1 million light years across. So it's huge. And you can pick this up faintly, but you can in binoculars under a dark sky. And I love doing this. And then spiral galaxies. Our Milky Way is a spiral galaxy, a class of spirals called barred spirals. To me, I get in trouble for saying this by my other astronomy buddies, but it's true to me. Spirals look like giant hurricanes to me. If you look at the one right here, doesn't that kind of look like a hurricane? But it has nothing to do with a hurricane. I'll get yelled at by my friends. But basically, these are star-forming regions. So spiral galaxies, in the spiral arms themselves, there's a lot of star birthing going on. Because what's happening here is you get some tidal friction within these arms and other things that are mixing together within these hydrogen regions to basically, I call them like a popcorn bag in a microwave. They just pop open clusters and stars, and then they go off and into their own areas. So let's see. So some spirals are more tightly wound, like M51 here, the Whirlpool Galaxy, whereas others, like the Andromeda Galaxy, are less tightly wound. The other thing about spirals, which is really important for binocular or telescope observers, is unlike ellipticals, if you remember, with ellipticals, it doesn't matter if you look at it from here or from here or from here, they look the same. With spirals, it really depends on your orientation. So these two galaxies actually look pretty similar to each other overall, but with the Andromeda Galaxy, we're seeing it kind of at a 45-degree angle or so. So that's why it looks kind of like this. Whereas the Whirlpool Galaxy, M51, we see from above. And so we're looking down at it. And so you can see it, the core here and then the spiral structure. And by the way, M51 is called an interacting galaxy because it's actually eating this little galaxy here, its companion, which is a separate galaxy called NGC 5195. But, and you can see kind of the mess it's creating as it's eating it. So that's a little bit about spirals. Now this is actually a very important topic. This is an illustration of our Milky Way galaxy. Remember I talked about how with spiral galaxies, it really depends on your orientation and where you're looking. That's really important when you're using binoculars and looking for things in our sky. This is basically looking down at our Milky Way, and this little blue box represents kind of the area where our sun is. It's out in the suburbs. If this is the core, if this is the city, we're out in the suburbs about 2/3 or so of the way to the end of our galaxy. And these spiral arms are here. So here's the Scutum Centaurus arm, the very important Sagittarius arm, the Perseus arm, etc. So our Milky Way is about 120,000 light years across. Estimates place it at about 200 billion stars. But because of our location and because of the density of these spiral arms, we could only see about 6,000 light years or so into our galaxy before everything gets obscured. Like we have no chance to visually see anything over here because we're looking through our core of our galaxy and it's way too dense. So if there's anything over here, we can't see it. We can see stuff over here. For instance, diffuse nebulae tend to be, like I said, in the spiral arms of galaxies. Here they are, these little red areas. Globular clusters tend to hang out in the halo, near the core of these spiral galaxies. So here they are, and we're able to see them. But another thing that's really important to notice here is at some parts of the year, we're looking towards the core of our galaxy. And at other times of the year, we're looking out, which is what these arrows represent. And when we do that, we can look out into the universe. So in some constellations in our sky, we can only see 6,000 or 10,000 light years away before we run into the dust of our Milky Way galaxy. Whereas down here, we can look billions of light years away, hundreds of millions of light years away to see other galaxies and other things that are out there. So it's all about perspective, orientation, and also don't forget, this is a 3D universe we live in. So if this was, if we look at it from the edge instead of from straight up and down, there's actually up and down to consider as well with outside of our galaxy. Therefore, we can see galaxies that are above or below our Milky Way, not just, opposite the core of the Milky Way, if that makes sense. Okay, I'm gonna switch here to something else. 1 second. Okay. Now, if you have a light switch or are able to turn off your lights, this is a really good time to do that. I'll give you guys a few seconds if you're interested in doing that. So think of it, you're on a rover trip, you're up in the boundary waters, you got your binoculars with you, and you look up. I won't say a whole lot for a few seconds here. I just want you to think about the sky here. It's midnight tonight is what this is set to. Okay, 7:15 at midnight. And the brightest stars are out. So here's Arcturus. It's a star not too much bigger than our sun. It's about 16 light years away. This is Vega from the movie Interstellar, if you guys remember, 48 light years away. The summer triangle. So here's Vega, Deneb, and Altair. This makes up the summer triangle. So one thing I like to say about stars is it's all in, every star is different. So when people look up at the summer triangle and I ask which star is brightest, they say Vega. But then I ask which star is the biggest, and they say Vega. And it's not, it's Deneb. And how do I know that? Because Vega's 48 light years away. Deneb is 2,100 light years away. So just think about that. You're looking out into one of the spiral arms here. This is Cygnus. This constellation is Cygnus. And you're looking into the Cygnus Milky Way. This is one of my favorite parts of the sky. If you take a pair of binoculars up here, all you'll see is wall-to-wall stars if you're under a dark sky. So some of the other more famous constellations that are still up here. Here's the Big Dipper, part of Ursa Major, the Great Bear. Here's a constellation of Hercules, the hero. Draco, the dragon, is here. Here's Ursa Minor, with its end star being the North Star Polaris. Cepheus, the king, some people know that one. Here's Cassiopeia, the queen. Andromeda, the queen, their daughter, Andromeda. Pegasus, the winged horse. And then we talk about our zodiacal constellations. So here's Virgo, which is for people that are born in September, I believe. That's your constellation. If you're born in October, it's Libra. I'm born in November, and my constellation is Scorpio. In December, it's Sagittarius. I think late December and into January is Capricorn. And then I think late January, early February, I think, is Aquarius. And then Pisces. So why do I say those months? Because that's when the sun is in this part of the sky. So for example, in September, the sun is in Virgo. Just let you know. So you have your pair of binoculars, you look up and you say, God, I can see the stars, I can make out these constellations, I see the Milky Way, but there's no objects that I can see in these little binoculars. Well, yeah, there are. You can see all this. Now, I won't walk you through all of this because it'll take way too long. I'm only going to talk about the brightest objects that we can see, but just know that you're not limited to that. There are other things that you can see in the sky. So let's get started. I'm going to start off with actually the spring constellations. These are constellations that are best seen in like March, April, but you can still catch them after dusk, say 11 o'clock or so, even this late into the summer. And I'm going to start off with Ursa Major, part of the Big Dipper. So here's the Big Dipper right here, if you follow my cursor. And this is the handle of the Big Dipper. There's a couple of galaxies here. The Whirlpool Galaxy, which I showed you, that was that galaxy we saw from above. That's right here. Really easy to find. If you just find the end two stars in the tail, in the handle of the Big Dipper and go down at a right angle right here, you'll find a glow. And that glow will be the Whirlpool Galaxy. If you go to the opposite side of these stars, and from a right triangle, you find the Pinwheel Galaxy, which is actually bigger than the Whirlpool Galaxy and a wondrous object in the telescope. But I've seen it in binoculars. You can pick that up from even the suburbs, I think. If not, definitely dark skies. You can do it. A little bit early. Oops. A little bit earlier, like say, soon, right when it gets dark, you may be able to still pick up Bode's Galaxy and the Cigar Galaxy in Ursa Major, the Big Dipper. They're right here. So you basically use these two, Dubhe and Merak. use them as a reference, and you can kind of make your way over in binoculars, and you'll see them. These are actually much brighter than even the pinwheel or whirlpool galaxy, and these are easy to find in binoculars. Easy to see anyway. So going a little bit further south. So here's again the Big Dipper right here. A little bit further south, the Sunflower Galaxy should be just visible in binoculars as a little glow. And the Black Eye Galaxy, which is actually a really impressive galaxy through a telescope, is right here as well. So the galaxies are here that you can see. If you go a little further into Virgo, if you remember I talked about Markarian's chain, that's in this part of Virgo, but it's getting pretty low now this time of year. Because remember, the sun is coming, the sun will be in Virgo in September, which is only in 2 months. So this part of the sky is going away, but in the spring, you can make out some of these galaxies. It's pretty cool to see. So think of those as fairly hard, but doable, even in 10 by 50 binoculars. Now let's make it a little bit easier. The globular clusters, some of my favorite things to look for in binoculars. So M53 is a globular cluster. So the way you can find that is use Arcturus. And so let me start with M3. So you find Arcturus, and you find this star. It's Mufred. From a right triangle with that, you find M3. You'll pick that up really quick in binoculars. It looks like a big fuzzy star. A little bit fainter than M3 is M53. So these two stars point almost right at it. I don't know why they call this the Rose Cluster. I've never heard of this before. It's M5 is what this should be called. This is another really nice, bright globular cluster to look at. In Hercules, so the way I find Hercules is I start from Vega, and I kind of just make my way over using these stars. This is called the keystone of Hercules. Some people have heard of that. And you find these two stars, you put your binoculars right in a line between them, you'll run right into the Great Hercules cluster of M13. M92 is also visible, but because M13 is so much more impressive, people tend to not even look for M92, but it's visible. And then there's a few other ones as you get into the constellation of Ophiuchus. So Ophiuchus is this big, grand, I think they call it a parallelogram. I don't know if I see that, but this is a big constellation that you can find easily with your naked eye. And once you determine where these stars are, if you scan through the middle of them, you'll pick up a few of these globular clusters. So this one's M10, this one's M12, and here's M14. Those are easy to see. The crucifix cluster, gosh, I'm not even sure what that is. Oh, M107. Yeah, I just saw this last week. This is actually really nice to see as well down here. So you'll notice that we're going from the galaxies, right, into this zone of globular clusters, right? Think of that previous slide that I showed you that we're looking down at our Milky Way galaxy and try to imagine why we're seeing galaxies over here.
Last year, there was no concert. They never called me back, but I checked their website today.
Sorry, did somebody say something? I just heard something. Okay, well, anyway, think about why you're seeing galaxies here and globular clusters here. It's because we're looking above our Milky Way and outside of it for the galaxies, but above the plane of the Milky Way here, which is why we're seeing these. All right. So it's midnight. If you're looking south, you're looking at the heart of our galaxy here. Let me tune down some of these. I need to have it up this high because of the galaxies, but let me see about tuning this down a little bit. That's a little better. So now we're in the city. We're looking at the core of the Milky Way right here. This is our big halo of our home galaxy. I'll make it a little bit bigger for people to make out. So remember we looked at that picture. We're out in one of the spiral arms, about 2/3 of the way out. We are looking right, if think of it as living in Eden Prairie and looking right into Minneapolis. And that's what we're doing here. Lots of stuff to look for in binoculars. So let me just start off a little bit to the west in the constellation of Scorpio. There's a big bright orange star called Antares, one of the largest stars that we know of, 640 light years away. Right next to it is a globular cluster called M4. That's really easy to find. So basically you find Antares and you find this star right next to it. and it forms a nice little triangle with it. Really easy to spot in binoculars. Just above our horizon are two open clusters, M6 and M7, which are these two. I'm sorry, whoops, sorry. Zoom in a little bit. It's actually over here in this area is M6 and M7. You'll just pick them up as big open clusters. And so because there's so many objects here, I won't go crazy and try to describe them all to you. But some of the brightest objects that we can see in the summer Milky Way are in this part of Sagittarius. So Sagittarius is called the teapot. Can everybody see the teapot here? So here's the spout of the teapot. Here's the handle of the teapot. So right here is the core of our galaxy. So people might remember last summer, astronomers had imaged the black hole at the center of our galaxy. That would have been right about here. So so the steam that's coming off the teapot is right into the core of our galaxy. So when you scan here through binoculars, it's all stars, all little stars, until you get into some of these gassy areas. So this is definitely a binocular object. This is called the Lagoon Nebula, also designated M8. And this is a nebula, I think it's about 7,500 light years away, I believe, and it's huge. This thing is bigger than the moon in our sky, and you'll pick that up in binoculars very easily. Right to the north of it is called the Trifid Nebula, which is not quite as bright, but pretty close to the lagoon. And you can sweep these up together in the same binocular field. So a 5-degree field is roughly about this big. And so you can sweep up both of them in binoculars. Moving over to the east a little bit is what they call the Great Sagittarius Cluster. I call it M22. And it's another globular cluster that's easy to pick up in binoculars. I do it almost every time I go out because it's so easy to do. Just find the top star in the teapot and just go slightly to the upper left. You'll run right into it. So scanning northward through the Milky Way, this is what we call a star cloud. It's called M24, and it's the Sagittarius star cloud, and it's wall-to-wall stars. If you had a telescope and you pointed here, you'd see wall-to-wall stars, thousands of stars. Through binoculars, it's just this dense, fuzzy patch, and it's huge. It's probably 3 or 4 degrees long, and it'll fill up your binocular field of view, just this one area. Two other nebulae you could pick up are the Omega or Swan Nebula, and the Eagle Nebula is also visible in binoculars. Those are fun to see. You could actually just barely maybe make out the shape of Omega. It's also called the Horseshoe Nebula. So again, in this part of the Milky Way, you've got a lot of gaseous clouds, nebulae, a lot of hydrogen and gas here. As you get a little bit further north out of the Milky Way, out of the center of the Milky Way, you come into these other spiral arms of the Milky Way. So here's the Scutum star cloud. And this is actually a very bright portion of the Milky Way. So think of it as really bright down here in Sagittarius. And then there's a little bit of a dimming of the Milky Way, and all of a sudden, another brightening. And when you scan through here, you'll pick up a few open star clusters, which is what these yellow designations are. And two of the more famous ones are the Wild Duck, which is also called M11. No idea why they call it the Wild Duck. It does not look like a duck to me, but that's what they call it. And that's easy to see. And there's M26 is actually pretty simple, and I think there was one other one. Anyhow, when you scan through here, you'll pick up a whole bunch. And again, 50 millimeters is the smallest binoculars I would use when doing this. If you have 70 or 80, it's better. You just need a tripod to hold them. So moving away from some of the brighter sections of the Milky Way, there's a whole lot of open clusters up here. None of these are too bright though. So you might just pick them up as small, faint, fuzzy patches. But along the way, once you get up into the constellation of Vulpecula, the wolf, there's this asterism. And what an asterism is it's a non-constellation that looks like something. So there's this famous one called the coat hanger. Let's see, there we go. Can everybody, it's upside down. Can everybody see the coat hanger? Here's the hook, and here's the line. Here's the hook, here's the line. Can you guys see that? So this is the coat hanger. It's just visible to the naked eye, but through binoculars, it's unmistakable. And this is in the middle of the Milky Way in the constellation of Vulpecula. Moving a little bit to the east, the Dumbbell Nebula was the first planetary nebula to be discovered, and it's pretty bright. It's on the fringe of naked eye visibility, but in binoculars, you pick it up as like a round, ovalish, grayish patch. Typically, when I do these presentations, they're outside and everybody has binoculars, so it's a little bit different for me doing it on screen. Hopefully, you guys are able to follow along. Okay, so now we're basically looking straight up. So let me give you a little bit of perspective here. So here's the horizon. So now we're basically looking almost straight up. The bright star Vega. Vega is part of the constellation of Lyra the Harp, and it has these stars called the trapezium. If you use the two stars here, they point to this globular cluster called M56, which is a nice one to sweep up in binoculars. Now we're heading into the constellation Cygnus, which I love to scan with my binoculars. There's not a whole lot here that's designated as objects that we can see, but it's really fun to just scan through here and see all those stars. You can tell we're looking to a spiral arm, and there's a lot of activity out here. Just nothing that's gonna stand out too much in binoculars. Once you get up to Deneb, there's this area here. Let's see if I can center on it. Let me. The North American Nebula is right here. And under dark skies, you can pick this up. So here's the Gulf of Mexico. Here's North America. Here's Florida. Here's Central America. Here's North America. Everybody see that? I've had trouble picking up the Gulf of Mexico in binoculars. Through a telescope, I've seen it. But you can try, especially if you're up in the boundary waters or someplace dark and you have binoculars, try for this. It's really easy to find. Here's Deneb, the bright star. It's right next to it. Let me get my bearings again. Okay, so south is down now. As you get up into the northern Milky Way, there's a whole bunch of open clusters and not much else. Remember we talked about the double cluster? That's visible way over here. Oops. Way over here is the double cluster. We're looking into the Perseus arm of the Milky Way here, and this is more of a late fall or early winter part of the sky in the evening sky. But you can, if you wait up past midnight, you can pick it up now, even this time of year. Well, I forgot to mention, an easy way to find Sagittarius right now is to find Saturn and Jupiter. There'll be the two brightest things in the sky when the moon's not out. Due south this time of year, or right now actually, around midnight, and they'll point the way to Sagittarius and the Milky Way if you're having trouble finding it. Let me just talk a little bit about the fall constellations. Going a little bit towards the northeast here around midnight, here's the Andromeda Galaxy, one of the finest objects to see in binoculars. The way I find it is to find this asterism, which is part of Pegasus, the winged horse. If you find, I think of it as a baseball diamond. Find the third base star, you star hop to this next star called Mirage, and then star hop up. That's how I find Andromeda. Under a dark sky, you can also see the Triangulum Galaxy as well. These are the two closest big galaxies to us. The Andromeda Galaxy is roughly twice the size of our galaxy, and the Triangulum Galaxy is about 2/3 the size of our galaxy. And the Andromeda Galaxy is only 2 million light years away, 2.2 million, and Triangulum Galaxy is about 3.3 million. Some of the other galaxies we talked about are 40 or 50 million light years away, so these are very close to us. And again, just to reiterate, once you get past Deneb, you're getting into the fall Milky Way and then the winter Milky Way. And you can see you get away from a lot of the gaseous nebula, and it's really mostly open clusters. And then finally, towards the southeast, there's a few more globular clusters. Here's M15, called the Perseus cluster. Easy to find by star hopping off the first space star in Pegasus, the winged horse, and then just star hopping right to it. M2 is in the constellation of Aquarius, right here. And then the jellyfish cluster is called M30. That's another nice one that you can find in binoculars as well. So let me get out of this and go back. Where's my cursor? I guess I gotta do it this way. And if people have questions about this, I certainly try to answer for you. Okay, so I know I've thrown a lot of information at you. I'm gonna send out this presentation as a PDF probably tomorrow. Oops. Near the back of this presentation, I gave you a table of the objects that we just talked about. So here's their designation, if they have a name, the type of object, the constellation that they're in. The magnitude scale is basically, we can see up to magnitude +6. And the way the magnitude scale works, from every magnitude you go up on the scale, the object is 2.51 times fainter than the previous magnitude. And negative objects are the brightest. So the more negative, the better. And then as you are in the positive range, we can, with our naked eye, see to about +6. With 10 by 50 binoculars in a dark sky, we can probably see down to +8 or +8.5. So I only included objects that were in that range. So there's about 45 objects out here of different kinds. We've got galaxies and nebulae and globular clusters, a double star, 1 or 2 asterisms, and a few others that you can try to find. So some helpful articles and books if you're interested in getting into binocular observing. I gave you some links here. Again, when I share the deck, all you have to do is copy these links, throw them into your browser, and it'll open up some nice articles for you. Star maps and books. I recommend the Sky and Telescope Pocket Sky Atlas. That's what I would use if I was using binoculars. The Cambridge Sky Atlas, Star Atlas is also pretty good. Observing the Night Sky with Binoculars. I just got this book, and it's pretty good. I can recommend that. This one is recommended by other people. I do not have binocular highlights, but I hear it's pretty good. The Astronomical League is the parent organization of all of the U.S. astronomy clubs. And they have this really cool observing program, or set of observing programs, more than 100 of them actually. And some of them are actually for people with binoculars. So you can get a list of objects, they're Messier objects, which I'll talk about in a minute, that will be conducive to looking for in, say, 10 by 50s. Deep sky binocular, galaxies and clusters. If you're interested in seeing double stars with binoculars, here's a list that you can use. And then there's a list for looking at the moon and solar system objects like asteroids and planets. And for people with phone apps, I use Android, so I really love Sky Safari. You can get it for both Apple and Android. I also have the mobile observatory, which is pretty good. And these other ones are just from talking to people and just looking to see what was popular. So Google Sky, Stellarium, and then on the Apple side, Go Skywatch, and then the Sky Guide was recommended. So what are some good beginner lists to see different kinds of objects? We talked a little bit about the Messier list. Most of the objects that I pointed out in the sky were Messier or M objects. Messier was a famous French astronomer from the late 1700s. He wanted to find comets because if you found comets, they were named after you and you would become famous. So he really wanted to find comets. But he kept running into these fuzzy patches in the sky that he couldn't quite make out. He thought they could be comets, but they didn't move. So he knew that they weren't comets. So in frustration, he started to catalog these objects. And now we have the famous Messier list of basically 110 best objects in the sky. And about half of them or so are visible in binoculars. So, and the nice thing about this list is it contains pretty much everything. You've got different kinds of nebulae, planetary nebulae, star clusters, globular clusters, star clouds, supernova remnants, a lot of different things that you can look for. So this is where I would start. There's a second list, a more modern list put together in the 90s called the Caldwell list, which is objects that Messier either forgot or just missed somehow. And there's another 109 or 110 objects in this list. Probably 20 to 30 of these are also visible in binoculars, some of the brighter ones. So these are a couple of lists that you could Google or purchase a book on or read an article about and go from there. So with that, I said keep looking up, and I'll open it up to any questions.
You know how some of the clusters got their names? There's like Flying Unicorn Cluster and Tweedledum.
It's maddening. It really is. I grew up with a certain names for certain objects, and in more modern times, there's other names for the same objects, and people have discovered other objects, and they have other names. There's no rhyme or reason why some of these objects are called what they are. Some look like the object they are, like the coat hanger looks like a coat hanger, but the wild duck cluster I'll never understand. Doesn't look like a duck to me. I don't get it.
Wasn't there, I can't remember if it was a comet or something that's going by our area now that they've talked about seeing? Where is that going to be located?
So there's a bright comet out right now. The brightest comet for me since the 90s. It's called Comet Neowise. So this is called Stellarium. Stellarium, and it's a free software. So it's Stellar and then ARIUM. It's not the easiest to use. It took me a little while to get used to it, but this is a really good one to have. There's also a phone version and app, but the app isn't nearly as good as the desktop version. I have both, but this is what I use now. When I shoot my images, I will frame things using the software, and when I'm planning for things like this comet, this is what I go to find it. So great question. So Stellarium is where I would go. I don't want to get too far into that path, but basically I'll just give you an example. I have a whole bunch of different cameras and telescopes that I use. This is, I can't see because the people are in the way. So if you had a 50mm camera lens, this would be your field of view. So what I would do is, so Neowise, so I'm getting a little ahead of myself here. So in an hour from now, I want everybody to go out, look to the northwest. It's clear outside, right? I can't see from here. I hope it's clear. Here's the Big Dipper. Follow it down to here. Okay? And if you scan with binoculars, I've done this a few times the last few nights, even from the suburbs, and I found the comet this way. So a little background on this comet. It was discovered on March 27th by the Neowise program. Basically, it's NASA's near-Earth orbit, wide angle, I forget the other two letters, but it's basically the satellite that's looking for the doomsday asteroid that's going to kill us. So it takes pictures every night, and every so often it picks up comets. And it picked up this one back on March 27th. And at the time, they thought maybe it could be bright, but we've been burned this year by two other comets that disintegrated before they got too bright. This one has stayed together. So it was in the morning sky, and it's slowly coming up into the evening sky. So what I mean by that is, so here's I have it set for tonight, right, at 10 o'clock. Watch what happens to the comet when I change the date. See how it's moving? 3 days, 4 days, 5 days from now. So this is the software that I use to plan when I go out observing. So in 10 by 50 binoculars, I can tell you can definitely see the core of the comet and the tail. The tail points to about the 1 o'clock or 1:30 position after dark, if you point northwest. So here's northwest, north is over here. Find the Big Dipper right here and scan down from there. And the comet, in the morning, and when I was looking at it in the morning over the weekend, it was very easy to see with your naked eye. And now, I don't know if it's quite as bright, but you can definitely still see it with binoculars and see the tail. And if you want to see a picture of it, I guess I could show you that too. So this is what the comet looks like through a telescope, and taking a sequence of pictures and stacking them on top of each other. All right, so there's the comet, a picture of the comet that I took a few days ago.
Wow.
So you can see the tail. The tail extends, remember we talked about degrees? The tail, some people are seeing the tail out to 15 degrees. So in binoculars, that would be at least 2 or 3 different binocular fields of view.
Wow.
I haven't seen it quite that long, but I've seen it go out of my 10 by 50s. So I've seen it to about 8 degrees. Let me show you a little video that I put together.
That's beautiful, Suresh.
Thank you. So here it is, rising. Here it comes. Everybody see that?
Cool.
So this is a movie taken over about an hour and a half of time. So these are all individual frames with my camera, and then I created a movie out of it. So I think I started this about 2:45 in the morning, and I ran to like 4:15. It's rising in the northeast here. This is in the morning sky. When we looked at where it'll be in an hour, it's setting.
Okay, so if the comet is going across the screen from left to right, why is the tail going toward the top of the frame?
So
Unless I'm totally missing something.
no, it's a great question. Does somebody else know the answer?
Earth is turning.
Well, not the Earth. Well, that's why it's rising. But why she's asking, why is the tail pointing up? Think about it.
Oh, it's the Earth is rotating and so we're looking at it in a different angle?
No, that's not.
How about gravity?
No. Well, it is gravity in a sense. I'll give you the answer. It's pointing opposite the sun. The sun is down here. So here, let me show you in a different video. Maybe that'll help.
And are you staying awake this whole time and doing it, or do you set it on remote control?
No, I'm awake. Trust me, I'm awake. So here it is later in the morning. This is like from about 4 o'clock to 4:15 or so, as dawn is rising. So the sun is almost rising. We're on Lake Minnetonka here, so you can see the lake. And you can see the tail is pointing exactly opposite of where the sun's going to come up. So the sun's going to come up. So basically the sun is right about like this, where my cursor is. Does that help to make sense?
So does the comet tail rotate as the sun's position changes?
Yes. Yes.
Sorry to ask all these dumb questions.
No, it's good. The comet's position's changing. It's actually coming closer to the Earth. So we're going to see a different side of it over the next few nights. In addition to it being, changing relative to the sun too. So any other questions?
Suresh, is it going to be usually about that part of the sky that you indicated, or
Let me go back to the other screen. So what's happening with the comet is that this is going to get confusing. Last week, it was better to see this comet in the morning than in the evening. But now, because the comet is moving, it's actually moving into the evening sky. So over the next few days, you can see it in both the evening and the morning. But after about today or tomorrow, it'll be better in the evening than it will be in the morning. So remember I showed you this, and here's the comet. And over the next few days, look how the comet's rising in the sky. See that? So now it's over here. This is on the 26th. So it'll be really easy to find here, because here's the bowl of Big Dipper. With binoculars, just come down and you'll run right into it. The problem is it's also moving away from the sun right now. So it's fading. It's fading over time. So I can't tell you how bright it'll be in 10 days, but I can tell you it's pretty bright now.
so it'll be still in the area around the Big Dipper, though? We don't need to look for a different constellation for it.
So
Okay.
over the next week or so, look
Awesome.
near the Big Dipper.
So if
This
the comet was just found, has its path been figured out yet, or do you have to track it over time to figure its?
No, we know its orbit pretty well. This program actually, you have to update it, but when you update it, it brings down the latest information and it calculates the orbit. So
will it be back in 100 years or 5 years or something like Halley's Comet, where you can know when it will come back already?
it'll be back in 7,200 years.
Oh,
So get ready for the next time.
we'll wait up.
Will you be doing the presentation for that one then too, Suresh?
I hope to, yes.
So, I'm interested in all the math, but you don't have to go into this. But somehow they can calculate speed, or
Calculus, it's all calculus.
it's all calculus. Okay.
That's actually a segue to that. That's actually how calculus got invented. Isaac Newton was trying to figure out a way to understand these orbital motions. And his benefactor was a guy named Edmund Halley. Recognize
Oh,
that
okay.
name? And Edmund Halley was an astronomer royal. He was the main astronomer in England, and he was pretty rich. And Newton was pretty poor, and he couldn't publish his research. So Halley was trying to prove that he had found a comet that came by every 76 years, but he didn't have a way to do it. So he funded the publication of something called the Principia, which was Newton's first book on calculus, and it made Newton famous, but it also made Halley famous because using that information, he was able to prove out that Halley's comet exists.